Okay, so on the equilibrium lab, what we're going to use is these little force tables. And although I cannot find for the life of me a protractor that has trig angles on it, the equilibrium lab, this table has 0 here, 90 there, 180 there, 270 there, and then also this is 360, right? And the idea is that we're going to put different masses here. So we're going to invent a force called a gram weight. It's not so far off. Some engineers use like kilograms as force. I would never do that. Okay? But we're going to talk about a gram weight is our unit of force. I used to have the kids take the grams, convert to kilograms, then convert to newtons, and then nobody understood this lab ever, right? Or maybe they just hated it so intensely. So we're just going to go with gram weights as the weights, the forces that we're using, right? And then the idea is that we're going to take these guys and put them in not such an easy configuration. So maybe like this, and like this, and like this. Kind of mix things up a little bit, right? And you can see exactly what angle you're putting things at. Put different amounts of mass. Don't put like a kilogram on one, and I would put like 100 grams to 200 grams on each one of these things, right? The pan itself has a mass of 50 grams. Don't forget that, okay? And then you're going to find there's going to be some angle, like right here, and some amount of force that's going to put this system in equilibrium. And you know it's in equilibrium when that little center thing can sit there and not touch the post. Yeah? You can pull it away from the post and it'll just sit there. Yeah? Okay, and you can kind of, once you put the weights on these things, you can actually, I'll show you this. I'll put 100 there, put a 50 right there. Okay? You can actually kind of guess where that angle is going to be, where that equilibrium is going to be, by just pulling on this guy. Right? I could sort of tell that this one's going to be somewhere around between 250 and 260 degrees, which is kind of fun, right? So what you're going to do is you're going to use the skills that you now have, I'll show you a little bit more, right, to calculate what the equilibrium should be in grams, and then put that amount on there. When you put it on there and it does come to equilibrium, you then have to go ta-da. Okay? Ta-da looks like this. You have to do this. You have to go ta-da, right? It's like a ta-da kind of a thing, right? And I'll come around and I'll take your picture to do the ta-da, right? Okay? To do ta-da. Am I actually speaking English? Okay. So what you're going to do, your little table, and you're going to do 2 of these because we want to make sure that the first one wasn't an accident, right? Okay. So your table is going to look like this. You've got A and B and C, right? And you've got the magnitude, and you've got the angle. And this is going to be the trig angle. That's what it really will be, right? Okay. And then you're going to have X and you're going to have Y. Why? Because I love you.
Thank you.
Okay. So set this up. I had some kids like doing this with like rulers, drawing out a real nice thing, right? And then probably I like to do this. I like to go A plus B plus C equals, and then the equilibrium. Right? Okay. So for example, one of mine is 30 degrees and 150 grams. So the magnitude is 150 grams, 30 degrees, right? And then the next one is 95 degrees and 100 grams. 100 grams, 95 degrees. You guys in the back probably can't read that writing, can you? No, I'm purposely not writing numbers down there because then kids think that they like have to do what I did, but please don't. All right, and then this one's is 50, and I'm sort of acting as if I'm doing this. And this one is 154 degrees, right? 154 degrees and 50, right? And then you're going to figure out the X components and the Y components, X and Y, add them all up, and then, yeah, find the equilibrium. And then you have to, then it's sort of like IQ on the line. I had some kids last period where like, they would figure this all out. They'd have these things and they go, okay, the equilibrium has to be over here. I don't think so. You probably made a mistake with the angle, right? It's going to be like over here or something. So it's sort of a good sort of check here. We do solve a little engineering problem, yeah? Okay. So that's the deal. These mass sets that I got when the school opened cost $45 each. I think they're like up to $55 now. So be nice to them. Don't pick them up by the bottom. Always pick them up by the little lever because they fall off They all fall off and fall on the floor if you try to hold them by the bottom. Okay, and then I just don't want, don't be sitting back there gambling with these. I don't want you guys going, well, I see your 200, and I'll raise you 100. Okay, none of that. Okay, just but these are precision masses. They are presumably the mass that they say down to 1/10 of a gram. Some of them, if you notice, have little holes drilled in them right in there, right? That's, I guess, because they must make them a little too massive, and then they drill holes in them to make them the correct mass, maybe? Yeah, I think so. So do this. You're going to do one of those, and then you're going to do another. So just do this by 2. Yeah? Oh, we're out of time. Kidding. And then